Now we take another example, that is example number 2. Let x1, x2 up to xn be the IID random sample from the PDF given below, that is f of x theta e raised to power minus x minus theta, where x is greater than or equal to theta and theta ranges from minus infinity to plus infinity, and other than this range x is greater than or equal to theta, it is 0. So we want to test actually h naught, that is theta is less than or equal to theta naught, versus h1, that is theta is greater than theta naught. So this is some sort of composite hypothesis. So our task is that how we find the likelihood ratio test for this type of hypothesis. So how we proceed for this one? Actually this is sort of negative exponential distribution. So to find the maximum likelihood, we need actually to choose theta as large as we can. But we also keep in mind that we have a constraint. We have the constraint that is actually theta is less than or equal to x. Actually that is actually the range of x. So which means that theta is less than or equal to x. So we pick the smallest x, because theta जो है वो x की हम smallest value select करेंगे. So that is actually x of 1. So the likelihood function will be, in this case, based on the smallest observation of the data x, that is actually e raised to power minus some xi plus n theta when theta is less than or equal to x1, because we are picking this on the basis of the smallest observation, and 0 otherwise theta is greater than x1. So let we call it equation 1. So x1 is our maximum likelihood estimator of theta and is an increasing function in the range of minus infinity less than theta less than x1. इस रेंज में this function is increasing function. So the denominator of the likelihood ratio test in is as in 1. Very obvious, जब इस रेंज में होगा कि माइनस इन्फिनिटी लेस देन थीटा लेस देन x1 होगा, तो डेफिनेटली इसका लाइक्लीहुड फंक्शन वही होगा जो हमारी इक्वेशन में दिया गया है, इक्वेशन 1 में. लेकिन we also know that because we have to find the ratio of the basis on the likelihood of the null hypothesis and the likelihood of the full parameter space, so we also keep in mind what is our null hypothesis. So we have an additional constraint. Actually that is based on the null hypothesis. Null hypothesis हमारा क्या है? That is theta is less than or equal to theta naught in the numerator. You know that the likelihood ratio test basically क्या होता है? Likelihood function based on the null hypothesis and divide by the likelihood function of the full parameter space. So that is actually based on the numerator. So we have two possibilities now. Now we have two possibilities as number one, basically if x of 1 that is the minimum observation less than theta naught, तो ऐसी सूरत में तो हमारे पास जो लाइक्लीहुड फंक्शन होगा वो वही हो जाएगा. देन ये जो कंस्ट्रेन है ये इसके ऊपर कोई इफेक्ट नहीं करेगी. देन दिस कंस्ट्रेन has no effect. So our MLE is same as the restricted MLE. So in second case, if x1 is greater than theta naught, now in this case the things will change. Then we have to choose x1 without violating the condition which is in our null hypothesis, that is actually theta less than or equal to theta naught, and we take the ratio of two likelihood so in this case the numerator is L of theta naught given x, this. Now the ratio, likelihood ratio test is for two conditions, that is actually, as I said, for the first condition it has no effect when the numerator and the denominator will same, so that is 1, and that is for when x1 the smallest observation is less than theta naught. In the second case, that is actually जब आप इसको डिवाइड करेंगे तो the net result will be that is e raised to power minus n into x1 minus theta naught for x1 is greater than theta naught. So that is actually the likelihood ratio test. So we reject H naught if lambda x less than or equal to k, and this implies that the rejection region is, that is x, where x actually x1 greater than or equal to theta naught minus log of k over n. So note that the rejection region depends on the sample only throughout the sufficient statistic x1 in this case. So that is actually the rejection region.